Assalamualaikum and selamat sejahtera. In the past 2 weeks, you had learned about single-phase uncontrolled rectifiers with resistive and inductive loads. This time, you will apply all the knowledge gained from the previous topics to understand the operation of single-phase fully controlled rectifiers. As mentioned in the previous videos, the only difference in the circuit topology of both rectifiers is the type of power switches. For this topic, we will only consider thyristors as the power switches of the controlled rectifiers. By using controllable power switches, hence, the operation of the rectifiers experience a slight change. To highlight the differences, I will begin all my explanation with uncontrolled rectifiers. First, we will start with the circuit topology. Based on the circuit of both half-wave and full-wave rectifiers, we can see that all the circuits are constructed using diodes. Now, let's convert the circuits to be controlled rectifiers. As you can see, the framework of each circuit is remaining unchanged except the power switches. Next, we will focus on the principal operation of the rectifiers. As discussed in the previous videos, I said it is easy to explain the principal operation by referring to the supply voltage waveform. As you know, during the positive half cycle, diode D in the half wave, diode D1 and D2 in the bridge, and diode D1 in the split supply rectifiers are forward biased. It is because the polarity of the anode terminals is positive. Automatically, the diodes are turned on and conduct the current. Now, we will consider the principal operation of controlled rectifiers. As you can see in the flowchart, the thyristors is not working in the forward bias even though the anode terminals is positive. Instead, the thyristors are ready to work in forward bias with the presence of a control signal. Once the control signal is applied to the gate terminals, the thyristors are turned on and conduct the current. In conclusion, the thyristors must meet two requirements before they can turn on. First, the polarity of the anode terminals must be positive. And second, the control signal is applied to the gate terminals. Meanwhile, during the negative half cycle, thyristor S in the half-wave rectifier is turned off. However, in the full-wave rectifier, thyristor S3 and S4 in the bridge and S2 in the split supply rectifiers are turned on when the control signal is applied. By considering the whole operation of the control rectifiers, we can conclude that the time of injecting the control signal determined the starting time of the current conduction. Based on the graph, the time is referring to the angle value at the x-axis. Then, we can use these equations to sketch voltage and current waveforms. In this video, I will not discuss how to derive these equations anymore, and you need to refer to the previous videos related to this topic. Now, we will consider a control rectifier with resistive load.